Thanks very much, Shahid and the MMF. Once again, a great pleasure to be here, and an excellent warm-up act from Matt for what's coming up. So what we call the standard of care, what people get across the planet for this cancer, we've worked it out in terms of chemotherapy, at least. We've worked out in a fairly logical, sequential pattern over the last 15, 20 years ago. I'm looking at Juan, and really that this is what you should get across the planet. We start, in fact, here with the adjuvant studies. So that's treatment that you get following surgery, and that's the BILCAP study is still which we did in the UK, is still the international standard, and that's 6 months of tablets after your operation. The first line treatment, in other words, the treatment that you get when you're initially diagnosed with advanced cancer, was established by the ABC-10 study by Juan and I in a very long time ago now, and only very recently superseded by the addition of immunotherapy to this treatment. So that's cisplatin, gemcitabine, and immunotherapy in this country, durvalumab, in other places, something called pembrolizumab as well. And then in the second line setting, this is Angela's publication from 2019, I think. So when this first treatment fails, you then move on to the second treatment. And then more recently, there have been a couple of publications about neoadjuvant treatment, so that's treatment before surgery to try and get you to a point where you can have surgery. And that's 2 chemotherapy schedules. I would argue both of those are still somewhat preliminary, and we're still looking into exactly how they fit into what we do, and actually how good these data are. I personally am not so sure, but that's a different conversation. So this is what we call the standard of care with respect to chemotherapy. And really, are there any advances? Are there likely to be too many more advances on that? Probably not. These is what I call the also-rans. So these are the other studies using different chemotherapy agents and other types of agents that have been negative. Arguably, the one that got away was ABC-3. Cediranib should really have been positive had we made it big enough, but sadly at the time, for various reasons, we didn't. So perhaps more chemotherapy and other stuff added together in this way is not going to work. And which brings me on nicely to the real excitement in this cancer, which is the genomic developments. And these and the genomic targets, as Matt has very elegantly described. And these really emerged probably about 10 years ago now with the ICGC, so the International Cancer Genome Atlas, describing the pattern of genomic changes in cholangiocarcinoma. And it is really rather special. It is probably unique in cancers in that it's anatomically specific, so different bits of cholangiocarcinoma have different alterations which you can target, and they tend to be mutually exclusive. So if you have one of them, that's it. Generally speaking, you haven't got another one, and your cancer is completely reliant on this bad actor, and consequently it makes it particularly vulnerable to treatment, which is, for all sorts of reasons you'll see, is a good thing. And roll on 10 years, and we now have 1, 2, 3, 4 approved, in most countries, approved treatments for these targeted treatments. And I've put in here, so these are all the studies here, and I've compared it to FOLFOX, which is our chemotherapy second-line treatment. And I've put in here, these are mostly relatively small studies, and so I've put in what we call the hardest endpoint that we have, the most reliable measurement, which is the overall survival in red. And so with FOLFOX, the overall survival is 6 months. That's pretty terrible. I mean, we led that study. We're not particularly proud of it. If you have an IDH1 mutation, the studies are now coming out with overall survivals of 15 months. The BRAF alteration, 14 months. The FGFR2 fusions, 21, 22 months. and most recently zanidatamab, which was approved last Thursday by NICE, 18 months. So this is a step change. This is a real advance in the ability to be able to offer both survival and very good survival for our patients. The best example, to be honest, is the IDH1 data here. So in the very original IDH1 study, which was 5-6 years ago now, the advantage in the study was, the primary measurement of the study was what we call progression-free survival, which is how long you're on the tablet before things go bad. And that was only about a month, 6 weeks, something like that. And so we were terribly disappointed. But here we are, despite the fact that it only apparently works for a month, people live for a lot longer. And there are in my view, there are two good reasons for this. One, that the treatment is different. It's a sort of biological treatment. You're changing the nature of your cancer. You're not just trying to kill it off. And also the tablet itself, ivosidenib, the NICE-approved tablet, has really very little in the way of side effects. And so while you're on this tablet, you have effectively no side effects from the treatment, unlike the chemotherapy, which takes it out of you, and the attrition of sustained chemotherapy, as we saw from the ABC-6 studies, is quite significant. So really, you're in pretty good shape through this treatment, and that permits you to get on with, not only to get on with life, but to entertain other treatments and studies and so on and so forth. So the quality of life factor here is great. So all of these are for, at least most of them are now approved in most places across the world, and that I think is a step change in what we can offer people. We are, however, not very good at it. And these numbers are not necessarily related, but I'll take you through them and you will get the message. The top number here is the cholangiocarcinoma diagnosis of people who were admitted to hospitals. So in COVID, we're allowed to do anything. And we got these data for every single person who was admitted to hospital in 2020 with the diagnosis of cholangiocarcinoma, and that was 2,900. This is a number I've derived from Shahid studies with the AMMF, and so that's roughly similar. We reckon that's a significant underestimate, but nevertheless, it's a number out there. So every time we prescribe an expensive drug, I have to fill in an online form called BlueTech, and you can get the data from BlueTech about how many people had first-line treatment. In other words, how many people were treated for advanced disease. And that was in 2020, in 2024, that was 1144, so 1,400 patients. So that actually tallies quite nicely with what Shahid was saying. Well, it's fairly shocking still, but it tallies with what Shahid was saying about the fact that only about half of people actually get treated with systemic treatment. So there's a huge drop here between diagnosis and treatment, and we've still got to get our heads around that and work that out and figure out the best way of trying to deal with that. It's actually not completely unique to cholangiocarcinoma. These numbers, there are similar numbers for esophagogastric cancer and other difficult to treat cancers. The next number down here is the GLH requests. So Matt described where all the tests are done in 7 places through the UK, and the requests so there's a code, M220, for cholangiocarcinoma, and the number of M220 requests in 2024 was 1,140. So this suggests that if your doctor started you on first-line treatment, he was also sufficiently sensible to request your genomic testing. So that's a bit reassuring. But, and this is the slightly alarming thing, the same number, and you would expect out of that approximately 10 to 13% or so people to be positive for something like IDH1, but the number of requests for the IDH1 drug, ivosidenib, in 2024 was 29. So that's another huge drop. That's another huge drop in the number of people who could have the treatment and the number of people actually receiving the treatment. And there'll be a little bit of explanation for that coming up, but as a rule, we're not sure what that is. And this is not to do with evosidenib or IDH1. These numbers exist for the FGFR2 drugs and other targeted drugs as well. So it's us. It's not the drugs or indeed the genes. So I'll take you through the ABC-10 trial, which is the big trial that we're running. I spoke a bit about it yesterday, and this perhaps illustrates some of the things that I've been trying to say and that Matt has explained this morning to you. So this is our big study that we're running with France. It's great to have Julien here, and Belgium. And it says here ABC patients 400, that was what the UK was allocated. Actually, where now the whole cohort between France and Belgium is going to be 1,000 now. We've gone up from 800 to 1,000 because we're doing quite well. And it's a very simple study in many ways. There are two bits to it. The first bit is the testing bit. So this is up here where your panel, where your material or biopsy is tested to see whether you have one of these genes that we've been talking about. And you simultaneously get a liquid biopsy. We've used Guardant 360. That's all sorts of reasons for that. But you simultaneously get a biopsy, and you will see, surprise, surprise, two tests appear to be better than one. You then, while this is going on, and while we get the result for this, you have your standard treatment, as described earlier, with chemotherapy and immunotherapy. And then we discuss the case in our molecular tumor board every Tuesday morning. It's a great show because we go through and we look at all of this incredibly interesting information about people, and we decide whether you tick one of the boxes on the right here, and if you do, you're randomized between the targeted treatment, so some of this stuff in bold, or just continuing on the standard of care. And if once the standard of care doesn't work, you cross over and you get the targeted treatment. So it's a question of when you get the targeted treatment rather than whether you get the targeted treatment if you tick one of these boxes. And I'll just give you an idea of the progress that we've had on that. We're doing quite well. So the proposed, so this is time and this is number of patients, and the proposed, what we thought we'd do was originally this grey dotted line here. We thought we would accrue like that, and the planned finish time was, I think, July or September 2027, something like that. In fact, we're on the green line, so we're well ahead of schedule. And even with increasing the numbers to 1,000, which is the amendment going through, we will be finished getting on for a year ahead of time. So that's, that says we can do this. The randomizations, in other words, how many people we put into that 2-to-1 randomization, is going pretty much to plan. And so there's a difference. You'll note that there's a difference between the people who are screening and the people who are randomizing. And I'll try and explain why that is, why the randomizations are not going quite as well as the overall accrual. Okay, and hopefully some of that will be here. So once again, these are numbers from, I think, about a month ago or something like that. So we've put in 643, so at this rate we'll be done in about September. And we've reviewed over 500 of those in our molecular tumor board. And we've identified 147 patients with alterations, and we've randomized 72. So a lot of people are not getting through to the randomization, and this has actually been slightly more than we thought, and we'll have to deal with this, but most of the time it's because the first-line treatment isn't working, but there are a whole lot of other reasons which we have to get to grips with, and that will be a tricky job. That will be a tricky job for Julien and I. But this is the surprising thing, and we're going to have to try and work that out. So this is how often we find a gene. So out of 514, we find a gene in about a third of people. So that's not bad. And this is what happens. This is the number of people who've received these treatments. So the study is actually, from this point of view, going to plan. And 1 in 3 patients, so 1 in 3 patients with a gene that you can hit, that's probably more than pretty much any other cancer that I know, apart from some of the very rare ones. So this is about the testing, and I think this for getting a bit niche now, I'm afraid, but of interest for some of us. So on the left is the testing for the biopsy that goes through, and the overall outcomes for the testing for the biopsy are sort of slightly disappointing, sort of in the late 60s. And this is primarily because, and the testing is different in different countries. In the UK, we use the North Thames hub, and you see the North Thames hub is doing quite well. That's a targeted panel, similar to which Matt has described, the RMH200, which is in fact used now in 3, or will be used in 3 of the 7 places in the country. So this is very reassuring in that we have a panel that actually delivers the results, or for the most part delivers the results. We've still got to work out why it doesn't work in some people. In some cases it's obvious there's simply not enough in the biopsy to do the test on. The great disappointment are the same providers in France. The same providers in France are not really delivering the results that we need. And there are many reasons for this, mostly logistical, partly technical, and so that's been the disappointing bit. The great success, I'm glad to say, thank goodness, is the liquid biopsy. So these are the liquid biopsy results here, and the liquid biopsy results are really very good. So in many cases, the failed tissue is made up for by the liquid biopsy, and we have a great deal to thank our collaborators for. This is tiny, but this is the last bit of the niche, I promise you, but of great interest to those of us who spend a lot of time on this. Most of the identification happens with the liquid biopsy. So these are all the different drugs that people have. So these people get futibatinib, these people get ivosidenib, these people are getting Zani. So this is the way in which it's identified. And most of the identification, despite the fact that tissue should still be king, most of the identification happens with the liquid biopsy. That's a big lesson. That is, in fact, a pattern that's seen with lung cancer as well. So we have to think long and hard about that. The tumor profile is doing less well. And this is, in fact, despite the fact that the liquid biopsy, just the technical aspects of the liquid biopsy means that it's going to miss some of these alterations. It misses some of the fusions that identified patients for futibatinib. It will do that. It's simply the technical nature of it. And you can see that's coming up to 10%. But despite that, the liquid biopsy is still the best way of doing it. So that may well influence the way we do testing in the future. The other really good spin-offs from our big study is the generation of other new ones. So this is proven. What I've just shown you is proven that we can actually do the testing. We can do the testing in people, and we can then treat people with the results of the tests. And this actually was not a given when we started, but fortunately it's transpired we can do that. And so now we're spreading out. So this is Julien's study. This is Julien's study to do exactly the same thing, but as adjuvant. So that's after you've had your operation. If you happen to have one of these alterations, you get the alteration together with the capecitabine tablet, and that's compared to the capecitabine tablet. And that's now funded in France and Europe, and we're waiting for CRUK to tell us whether they'll fund that or not. They'd be somewhat silly not to. So once again, this is, it's, for us, it's pretty reassuring that we do something, we prove it works, we can move on to the next thing. And other things, I showed this yesterday. So this is the main study I've just described you. So in addition to finding the usual suspects I gave you on the original list, we found other things. We found evocidinib, we found IDH2, which is I always refer to as the poor sister of IDH1. We found a significant number of IDH2 patients, and Servier, credit to them, are now going to support a study with their IDH2 drug. So that, once again, more people are coming under the umbrella. There's a BAT1 drug. Julien has submitted a proposal to Revolution Medicine for the RAS alteration, so this is potentially very promising. This is about up to 1 in 5 people. This is a radiation study that Maria was working hard on, but probably won't get anywhere. There are other propositions coming up for radiation. And then the SAFIR trial, which is the second-line study using a new immunotherapy agent called ivonescimab. So once again, the reassuring thing is that you do one big, simple study, and there are lots of spin-offs, and it's always reassuring when you get these spin-offs. And this is SAFIR, which I described yesterday, and this is going to test ivonescimab, which is a new bispecific. So these targeted immunotherapies, one arm of it, and as you saw the little diagrams of antibodies I showed yesterday, one arm of it is your standard immunotherapy arm, and the other arm is an arm to vascular endothelial growth factor, VEGF. So that's a new drug, and that's already up and running in France, and we hope to have that running in the UK within the next few weeks. Other spin-offs, so this is the vorasidenib study I told you about earlier. So a very simple study looking at IDH2 mutations. There's another drug here called tinangotinib, which works with following FGFR2 failure, and so that's coming up as well. And so you can see that one study does lead to a number of others, and that's very reassuring. And this is Julien's RAS study, which I described slightly earlier. So I hope that wasn't too much information in too short a space of time. You can see that we can do a great deal for a large number of patients. There is an apparent shortfall. We are not delivering as much treatment as we can, and there are some reasons for that, but all the reasons are not absolutely apparent. But most reassuringly of all, we can recruit into studies. We can recruit a lot of people into studies, and that's in large part because of MMF and the increased visibility of this malignancy to the general public, and they should be very highly credited for that. I think that's it. Thank you very much.